Welcome, GeoTrig. This is section 6.6, Trapezoids and Kites. The essential question is, what are properties of the angles, sides, and diagonals of a trapezoid? Let's begin. So what is a trapezoid? Just a reminder, maybe you did this in 6th grade. It's a quadrilateral with exactly one pair of parallel sides. So only one pair, doesn't have two. So in this case, the top and bottom are parallel. Some properties of this, we have legs, which are the two sides that aren't parallel. And then we have bases, which are the two parallel sides, and then we have something called base angles. And there's actually two pairs of base angles. So they're the angles that share the same base. So they're not all base angles together. We just got a pair down here and then a pair up here. So the bottom two are base, top two are base, but a top and bottom is not a base angle together. So an isosceles trapezoid is a trapezoid with congruent legs. This is a special kind of trapezoid. So just these two legs right here, going to be congruent. We have a theorem for isosceles trapezoids. It's that if a quadrilateral, let's go to the next slide before we talk theorems. So we have two theorems for isosceles trapezoids. So the first one, if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So the bottom two, this pair, is congruent, and the top pair, that pair, is congruent. So how could we prove this? If you wanted to look at the proof, what you got to do is you got to create a line that's parallel to RS, we'll call it parallel to AP. So it'll look kind of like this, and S would be right here, and these two lines right here are parallel. So if you did that, then you have the triangle TRS. It's an isosceles triangle, and then you got transversal and interior angles of the transversal being supplementary, and you can make that proof. Anyways, second theorem: if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So BD is congruent with AC. If you wanted to prove that one, you have two triangles here, BAD and CDA. They're congruent by side angle side, and then you look at corresponding parts. Alright, we got a few more vocabularies. We got the mid-segment of a trapezoid is the segment that joins the midpoints of the legs. So the sides right here, the midpoints would be M and N right here, and it's just a line between that. We did mid-segments before in last chapter for the triangles. So they have two properties for the mid-segments. The mid-segment is parallel with the bases, and then the length of the mid-segment is half the sum of the lengths of bases. So another way to think of that, it's the average. When it's half the sum, you add them up and divide them by 2, so half. So it's the average of both bases. All right. Another vocab word, we have a kite. What is a kite? It's a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. So like these two consecutive sides are congruent, and these two, and they aren't all congruent with each other. Why is it called a kite? Well, it kind of looks like a kite. So that traditional look of a kite. So what theorem for a kite? Well, if we do have a kite right here, we can say that, we put a line between B and D right here. We can say that AC is perpendicular to line BD. And why can we do that? We got perpendicular bisectors, that same theorem 5.4. You got an isosceles triangle up here and one up here. So it's perpendicular bisectors. All right, next thing. So we got a chart that's summarizing a lot of what we did in chapter 6. I thought it was kind of neat. So if you have a quadrilateral, certain, families of this are kites, which are off on their own. You got trapezoids, which have a special type, isosceles trapezoids, and then parallelograms, which have two types, rectangle or rhombus, and the combination of that is a square. I thought it was neat, so I'd show it to you. Anyways, let's do some examples. Pause the video. All right. Quadrilateral DEFG is a kite. What are the measures? Angle 1, angle 2, and angle 3. So measure of angle 1. So I've got this shape right here, and one of the properties I learned is we got perpendicular bisectors here. And because it's a perpendicular bisector, or these are going to be perpendicular lines, I know that, no, I don't know that perpendicular bisector, but I know that these two, EG and DF, are perpendicular. So I'm going to say EG is perpendicular to DF. Since those are perpendicular, I know measure of angle 1 equals 90 degrees. So measure of angle 2. If measure of angle 1 is 90, and this is 90, and this is 52, I know number 2 has to be just the leftover. So it's going to be 180 minus 90 minus 52, and that's going to come out to, 90 minus 52 is going to be 38. So measure of angle, I'll write that up here, measure of angle 2 is going to be 38. All right. Now, the last one, angle 3. This is because of perpendicular bisectors. So that is just going to be 52 degrees. So there's your answers. 38, 52, and 90. Next one. Pause the video. Alright, QR is the mid-segment of trapezoid LMNP. What is X? This is the mid-segment, and then this is the top base, and this is the bottom base. That mid-segment has to be the average of the top two. So the formula is the mid-segment, x plus 2, has to equal the average of the two. So it's going to be 4x minus 10 plus 8 divided by 2. Alright, so let's do the math here. Dividing all these by 2, that's going to end up being 2x minus 5 plus 4 equals x plus 2. Combining like terms, it's going to be 2x minus 1 equals x plus 2. I'm going to subtract x from both sides. So let's cancel. I get 2 equals x minus 1. Add 1. And I'm going to get x equals 3. So my answer is x equals 3. Next one, pause the video. Alright, CDEF is an isosceles trapezoid with measure of angle C equals 65. What are measures of angle D, E, and F? Okay, since it's an isosceles trapezoid, we know that the base angles are congruent. So a measure of angle F has to equal 65. Alright, now what do we know about these last two? Well, I know measure of angle D equals the measure of angle E, because those bases have to be congruent. And since we have two parallel lines, and then these are DC is a transversal and EF is a transversal, I know that we have the adjacent same side interior angles have to be supplementary. So the angle D is going to measure of angle D is going to equal 180 minus 65, which is going to be 115. So measure of angle D equals 115. That means measure of angle E must equal 115. So there's your answers. That's it.